Hi guys, I've noticed we're struggling a little bit with acceleration, and freefall is a really good example of our acceleration formulas because the acceleration is always the same. Our acceleration due to gravity is always going to be negative 9.81. So that's what makes this so excellent, is we know exactly what's going to be happening. So once again, acceleration is always negative 9.81. We have two different formulas we can be using here. I'm going to draw the little formula triangles. Sorry, they look so janky. So the formula on the left is going to be the one we use for when we have time. So this is acceleration with respect to time. We have our final velocity minus our initial velocity equals acceleration over time. Remember, we divide on the vertical line and we multiply on the horizontal line. Here, hopefully we can make that one a little less. Nope, still crazy. This is the tougher one. This is when you have displacement. So you have acceleration with respect to displacement. So that's 2 times change in displacement. And we have final velocity here, but it's squared minus initial velocity here, also squared. So those are going to be the two formulas we're experimenting with. We're imagining there is no air resistance ever. So here's the first practice problem we did in class. Imagine a baseball is dropped off a cliff from rest. What is its velocity after 5 seconds? So here's my deal. I'm going to go through the guess method. The first thing I have to do is underline my givens. So from rest, we know that's a given. From rest means 0. And if we started that way, we're going to say that's our V1, our initial velocity. All right. And what is its velocity after 5 seconds? I'm going to say that's the time. It helps when I'm underlining my givens to label them as well. All right, now I'm going to circle my unknown. What am I trying to solve for? So the problem says, what is its velocity after? So that after tells me I'm looking for final velocity. All right, now I'm going to write my equation. So I'm going to do the formula triangle here. Oh, not as bad as the last page. I'm getting better. Outstanding. Okay, so I'm going to use the formula triangle where we have acceleration with respect to time. Why this one? Well, because I was given the time. So my time, 5 seconds over here, I want to use the one it's with respect to time. So I have final velocity minus initial velocity. Okay, I'm going to circle my unknown in here, so I'm still on board, solving for final velocity. So I have my equation done. All right, I'm on S. Okay, so before I can substitute, I'm going to write my equation out fully. So I'm gonna ignore this part because this is what scares me. This is what I'm solving for. This is my unknown. So in order to get VF minus VI, final velocity minus initial velocity, so cover that up, I have acceleration. Remember, this is times, acceleration times time. So my final velocity, still don't know it, still my unknown. But here's where I get to substitute in. So I have VF minus what was my initial velocity? Well, we said it was over here from rest. So from rest is 0 meters per second equals acceleration. Acceleration due to gravity, we underlined on the previous page, always negative 9.8 meters per second squared, times our time, and we've established up here our time is 5 seconds. Okay, so here I have seconds on top and on bottom, so I'm going to cross out the squared because this is, remember, seconds per second. So I have VF minus 0 equals negative 9.8 times 5. I need to do this math problem first before I deal with whatever's happening with my VF. So negative 9.8 times 5, according to my calculator, negative 49 meters per second. Okay, but here's my deal. It's 0 this time, so I really don't have to do the algebra, but often it's not 0. So we're going to do it as if this were a number I had to get rid of. So in order to get VF alone, I would add, to get rid of this, I'm going to add 0 meters per second to both sides. So now I have VF equals negative 49 meters per second. So when I go to the next page, I see right there at 5 seconds, I got myself right, 49 meters per second. But now we have to talk about displacement, and displacement is the uglier of the two formulas. So we're going to start over. Same baseball, using my same final velocity I just found, so that was negative 49 meters per second. How far did it fall? So I've got my final velocity, I've got my initial velocity, started from rest. How far did it fall? How far? So I've underlined my givens, I circled my unknown. Now let's write out our formula. Oh, this is the business one. So we've got our acceleration with respect to displacement, so that delta D is displacement. And we have VF squared minus VI squared. So I'm trying to find this time how far. So my displacement. So I'm going to imagine this doesn't exist. So in order to get this to delta D, what do I have to do? I have to do what's on top divided by what's on bottom. So VF squared minus VI squared over A. Okay. So now we should be able to substitute. So I still don't know this business. Don't know what that is. So 2 times my displacement equals my final velocity squared. Negative 49 meters per second squared minus my initial velocity. Well, we started from rest. So my initial velocity, 0 meters per second squared. All over my acceleration, negative 9.8 meters per second. So every second getting that much faster. All right, I have to do this problem on the top before I can do anything else. I have an issue here with my 2 though. I want my answer just to be displacement, not 2 times displacement. So I'm going to multiply both sides by 1/2. So this side I'm going to do by 1/2. And that's going to cancel out my 2's right here. I'm also going to do this bad boy times 1/2. So that's going to put a 2 on the bottom with my 9.8. So now my calculator, negative 49 squared. I should have, I believe it's 2401. And when I square it, it becomes positive, minus 0 over, I did the math problem on top, now I have to do the math problem on top, bottom, 9.8, negative 9.8 times 2, should that be negative 19.8, math, equals, so I've got 2,401 divided by negative 19.8, because the minus 0 obviously does nothing for me. And I should get 122.5. Now we're talking displacement. So our displacement here, meters. This should be my delta D. And when we check on the next page, see right there, 123 meters. So it looks like we rounded. So not so bad. In the next video, I'm going to solve one of the problems from your homework. So please watch the following link so I can solve the video or the problem from your homework.